So next, we looked at this is a local case of ocean currents, but now we're gonna apply everything that we learned to look at global ocean circulation. And we're gonna begin with the equator again. So let's say that this is the Earth, and the sun is always shining. And what the sun's going to do is it's going to make the equator the hottest part of the globe. And the poles are going to be the coldest part of the globe. And so now we can try to see how the ocean current is going to move throughout the globe. So what's going to happen is that, so this is a repetition of what we looked at before. The hot water, it wants to move north towards the poles. So that's this section here. But as it tries to move towards the poles, the Coriolis effect is going to deflect it towards the right, so it winds up here. But eventually, it's going to reach the poles. So once the water reaches the poles, so I'll just write this here, ocean currents in air always follow this principle, that whatever is hot is going to move towards cold, and whatever is cold is going to move towards hot. So now these ocean currents will eventually wind up at the poles and they cool down, and what they're going to want to do is move back towards the poles. So I'll use this color here. So now once the current reaches the poles, it's going to want to move back towards the equator. But as it does, because the water is colder, it's actually going to sink to the bottom of the ocean as it moves towards the equator. That's a small part of the cycle, but that's essentially what's happening here. We're ignoring a lot for now, but this is the basic idea of the global ocean circulation pattern. So hot surface water moves towards the poles. As it moves towards the poles, it becomes cold, and as it cools down, it sinks to the bottom of the ocean, but it's still cold water, and because it's cold, it wants to go back to the equator, and it's going to try to move back towards the equator here. But that is not the only picture. The Earth is not a smooth ball. There are mountains on the surface of, on the continents, but also at the bottom of the ocean, the surface isn't smooth either. There's jagged areas, you have flat areas. So because of that, all of these underwater mountains and topography are also going to affect how the currents are going to move throughout. And on top of that, again, remember that there's the Coriolis effect. So because of that, you don't get just one loop around the globe. You get this entire pattern here so let's see what's happening actually over a small section. So you're starting off at the equator with a warm ocean surface currents. It moves towards the poles, and once it gets towards the poles, it cools down. And if you notice, it sinks to the bottom of the ocean. But it's still cold water, so it wants to go towards the equator, so it moves towards the equator, but then it passes the equator, and here it branches off around Antarctica, and so the path gets complicated. So but that's the big idea here. So let's go ahead and write this down. So this circulating path, it looks like a conveyor belt, so we call this the global ocean conveyor belt. Global ocean conveyor belt. And it's a complicated process, but we're just going to concentrate on the simple ideas. And the simple idea is this. The first thing is that warm always wants to go towards cold. So the warm ocean surface currents. So the warm ocean surface currents flow towards the poles. And once they get to the poles, the water cools down. And so let's talk a little bit more about this one here. So when the water reaches the poles, part of it turns into ice. So that means that there's going to be less water. Some water is going to be removed from the ocean, but the salt is still going to remain. And because of that, because salt is heavier, the salt is going to sink, and that is also what's going to contribute to this sinking current here. So that's something else, is that as the water cools at the poles, it cools to form sea ice at the poles, cools to form sea ice at the poles. And because there's less water with the same amount of salt, the water becomes saltier, and salty water is heavier than regular water. And so because of that, the salt is gonna sink and drag water along with it. So the salt that doesn't freeze, so the salt does not freeze, and because of that, it's heavier and it sinks to the bottom of the ocean. So to the bottom of the seafloor. But it's still cold, so it's going to want to move towards the equator, but it follows, because of the topography is at the bottom of the ocean is not even, it's going to spread out and move over the ocean, over the bottom of the ocean. So it'll spread out and move over the bottom of the ocean. And eventually, even though the topography, this is the Earth here, even though the topography is complicated, eventually it'll wind up back to where it started, but so in taking this entire path here. And there'll be a point where the water is going to start at the bottom of the ocean, and you can kind of see it up here. It'll rise back up to the surface as upwelling. So let's see what else here. So the path that it follows, it can take is between the ocean current. This ocean current path can take between 500 to 2,000 years. So take between 500 to 2,000 years to complete the cycle. But eventually it'll wind its way back up to the surface as upwelling. So eventually it'll return to the surface as upwelling. As upwelling. So this is actually what, this is going to be a big effect on climate, because different places, depending on where you are, next to these global ocean currents, like Europe, it's warmer than it would actually be if there were no ocean currents. And California here, it's famous for having cold waters off the coast. Okay. So there it is, global ocean circulation pattern. So we'll see this idea again when we talk about climate change.